light. So ray model light, very, very, very simply, is light travels in straight lines. We did this at the end of the unit before break. We did that lab where we saw the light bent off or bounced off the objects in straight lines. We saw it bent through the lens in straight lines. It was always in straight lines. Okay, no matter what, light travels in straight lines. There he is. Okay, light travels in straight lines. So then we're going to talk about the types of lenses. There are two types of lenses. First type of lens is convex, which looks like this. And the second one is concave. Yeah, let's do a different color. And that looks like this. Okay, convex lenses make real and virtual images. We'll talk about what each of those are in a second. They make real and virtual images. The reason they do is they focus the light to a point. That point, by the way, is called the focal point. That doesn't mean the light forms there. It just means that's where the light is focused to. It's trying to get to the focal point. Okay? So it focuses the light to the focal point. Concave lenses, they make only virtual images. That's a V, not a W. And again, the reason for this is they focus the light away from a point. So, convex lenses focus light to a point. Concave lenses focus light away from a point. Okay. That's just something you got to remember. Unfortunately, on this unit, there's a little more that you have to kind of remember than you do on other ones. But none of these are particularly complicated. It's just two types of lenses, convex, concave, and you just got to know that convex focuses the light together, concave focuses the light away. Okay. So far, so good. Real versus virtual images. So, real images, light converges at a real point in space. Okay, so light comes together at an actual, real, honest-to-goodness point in space. I gave you this example before break. I said the projection is a real image. It forms at an actual place in space, and the actual place is on that screen. I can put my hand there. I can actually see where the image is. Okay? If I put my hand here, now it forms on my hand. It's a real image. I can put my hand at the real place in space where it is. So that's a real image. Virtual images are a little different. So light appears, so it doesn't actually, so it appears to converge at a place in space that doesn't exist. Okay? It appears to form at a place that doesn't exist. Standing in front of your mirror in the morning, okay, in your bathroom, that's a virtual image. It looks like the light converges inside of the mirror, which isn't a real place. You can't actually go into the mirror. You can't fit your hand in the mirror. You can't put your hand where the image forms. So that is a virtual image. It doesn't actually converge there. It just looks like it does. Okay? But it doesn't really converge in that spot because that spot doesn't exist. Okay? So that's virtual versus real. Any questions on the definitions here before we draw the diagram? Okay, let's draw a diagram. First thing we're going to do is I'm going to show you how to set it up. We're just going to set it up. You're going to do this exact step exactly like this for every single problem. It doesn't matter what type of lens. It doesn't matter what the numbers are I give you. It doesn't matter what you're solving for. You set it up the same way every time. Okay, the first thing you do is always use a ruler. Never, ever, 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 ever freehand it. Don't you dare freehand it, okay? If you don't have a ruler, just find something straight, okay? Side of a stapler, some random thing you have that's straight, an ID card. I don't care what it is. It doesn't matter what it is. It got to be straight. Rulers are easier because they have numbers on them, so you can actually measure things easier. But like, if all I got is a stapler, I can I can do my units as like staplers. So it's like 3 staplers away from the lens. That would be hard because it would be huge, but you could do it. All right, first thing you do is you draw a line straight across your paper. It's called the principal axis. We talked about this before. I'm going to label all these things. On the problem, you don't necessarily have to label what the principal axis is. The principal axis is literally just a straight line. But it's the straight line that determines where everything else goes. It does not matter where you put it. I just put it in the middle. I just put it in the middle of the problem. Okay, then you're going to draw your lens. I'm going to use a convex lens for this first one. I generally put it in the middle, and I have the middle of my lens go through the principal axis. Does it really matter that much? Not really. It doesn't matter necessarily how big or how small you make it. You want it to be in the middle as best you can, but if you're not perfect, it's okay. This is the only thing you can freehand. You can freehand the lens, and I'll show you why in a second. Okay. So the lens you just draw kind of in the middle of your page. Okay, next thing you do is you draw a vertical line that goes straight through your lens and is perpendicular to the principal axis. I usually draw it as a dashed line so I can tell the difference between it and the principal axis. And you just draw it like that. It's called the axis of refraction. Again, that name is not important. It's where the light bends. For example, the reason I told you it doesn't matter how big your lens is because all your lenses are going to be different in size than mine. The reason it doesn't matter is because the light doesn't bend at the lens. The light bends at that point, at the vertical line. That's where the light bends. That way, everyone's light bends at the exact same point. It bends at the vertical line. It does not bend when it reaches the lens. Because some of you may have really skinny lenses. Some of you might have like big old fat lenses. And it doesn't matter. It doesn't matter because you're doing the refraction at that vertical point. Okay. So we've got the principal axis, we got the lens, we got the vertical axis of refraction. The next thing we need to put on is the focal point. I will give you the focal point for all of these problems. I will say the focal point is 10, or it's 3, or it's 2, or it's whatever. Okay? So I'm going to put the focal length. I'm just going to go ahead and I'm going to make a focal length of 2 centimeters. You can feel free to do what it is. What you want, but I'm going to go 2 centimeters for mine. So I put my ruler, my starting point is at that vertical line. I'm going to go 1, 2 centimeters. I'm going to put a dot there. And underneath that, I'm going to write F1. If you're wondering why I put f1, there's two focal lengths for this one. And the reason is lenses got two curves. So there's a focal point for the left curve and a focal point for the right curve. F1 is always going to be on the right. For convex, we're just talking about convex now. For the convex lens, always going to be on the right. F1 will always be on the right every time. But you have to draw a second focal point, and it's the exact same distance, but in the opposite direction. So mine would look like this. And that one is going to be called F2. And again, it is always on the left. For convex lenses, at least, always on the left. So now I've got F1, I've got F2. And again, if you look at this, like it looks a little, you're like, well, isn't F2 closer to the lens than F1 is? Well, yeah, but the vertical line is what matters. F1 and F2 are the same distance from the vertical line. Okay, last thing for the setup. You have to put where your object is. Again, I will tell you where the object is. I will say it's this far away from the lens. When you do that, you need to always measure it from that vertical line. Don't measure it from the edge of the lens. Measure it from the vertical line. Okay. I'm going to go ahead. By the way, I'm using the numbers from the example we're going to do just so you can see the setup, and then I can go quickly through it. So you put a dot at that point. You write O for object. The object is always on the left. Always, 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 always on the left. And then you draw the object. I'm going to, I use yaks way too often. I don't know why. I just felt like using yaks as the objects. You're welcome to draw a yak if you'd like. But if you would prefer to save time, just draw an arrow. Now, again, I will tell you how tall the arrow should be. So don't just draw the arrow any height that you want. Draw the arrow exactly how tall I say. Okay? So I will tell you where is the object, where is the focal length, how tall is the object. I will tell you that every time. Okay? Those three things. You have every single problem. So this is what your setup should look like. Okay? Your setup should look like this. Setup should look like this. Okay, I want you guys to try the setup, because I didn't tell you what these numbers are. Okay, so you guys may not have put them at the exact right place. I want you to try 6, the setup. I gave you the specific numbers for 6, the setup. I want to see if you can do that. Okay, 1 centimeter tall yak, 3 centimeters away from a convex lens with a focal length of 2. Find the image height, images, don't worry about that yet. For right now, just do the setup. So I want you to see if you can do the setup on your own. Okay? See what you're able to come up with on that one. And if you're having trouble, let me know and I will help you. Okay? So raise your hand if you got questions. I'll come around and help you check, make sure that you have it set up the right way. Again, by far the most important thing, use straight lines and draw them carefully, measure them carefully. Again, if you do that, you're going to be in great shape on these problems. So instructions for drawing the ray diagrams for the lenses. So step 1, we just did. Set up the lens diagram. And you're going to do the exact same things we did there. So you're going to draw the principal axis. You're going to draw the lens slash the axis of refraction. You're going to draw focal length 1 and focal length 2. And then you're going to draw the object. So these things up here, you can draw those exact things every time. And again, I'm going to give it to you every time, those things. It's never going to be a time where I won't give you those, unless we're doing a math problem. Math problems, I might not give you some of these. But for these diagrams, I'm always going to give you those numbers. Okay. Step 2. This is where I'm going to start using different colors. So if you want to use different colors, you can. If you're not, if you're like, no, Mr. B, pencil is A-okay with me. It's the Monday after spring break. I want to be boring. It's totally fine. Okay? All right. Step 2. You're going to draw a light ray. That starts at your object. And by the way, I'm going to start it at the top of the object. You could start it anywhere. It's going to be easiest if you start it at the top of the object. So draw a ray, starts at your object, travels parallel to the principal axis, then reflects through F1. Okay? That's it. Draw a ray, starts at your object, travels parallel to the principal axis, and then refracts. Reflects? Oh my gosh. Not only did I use reflect instead of refract, I didn't even spell it right. Goodness gracious. Sorry, it's Monday after spring break. There we go. Okay, so what does that look like? Start at your object. Again, I start at the top. That's where you should start. Draw it as a straight line parallel to the principal axis. So the principal axis acts horizontally across my page. So I need my line to go horizontally across the page. Start at the top. It goes straight to that vertical line. It does not go to the lens. It goes to the vertical line. And then it refracts through F1. So I start where it ended, which is at that vertical line. I draw it through F1 like this. And then I do something a little different too. I backtrack the line. The reason I backtrack the line is because this is where it looks like the light came from. Obviously, it didn't really come from there. It came from here. But if I stuck my eye here, it would look like the light came from this spot over here. The reason that matters is because sometimes the light forms over there. Remember we talked about virtual images? Said virtual images look like they appear in a place they can't actually appear. Light bends through lenses. It can't actually be on the left, but sometimes it looks like it's on the left. Not actually there, just looks like it's there. Okay, so that'd be an example of a virtual image. So I backtrack the line in case that's where it forms. In case that's where it forms. That's why that way I already have it set up. All right, so first line went parallel to the axis and went through F1, and I backtracked it. This next one will start at the same place. They'll all start at the same place. but they're going to go the exact opposite. So the last one, I drew a ray, starts at your object, travels parallel through PA, then refracts through F1. This one is going to be the exact opposite. The first stuff is all true. So draw a ray, starts at your object, travels, okay, blah, 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 blah. But instead of it traveling through the principal axis, okay, it goes through F2. So it went through F1 after it refracted. Now it goes through not F1, F2 before it refracts. So it goes through F2, then refracts through, refracts parallel to the principal axis. It's exactly the opposite. Exactly the opposite. You start in the same place, but other than that, it's exact backwards. It's not F1, it's F2. It's not parallel and then through F. It's through F and then parallel. Now, you do need to memorize that first one, obviously. Okay? But if you know the first one, then you can do the second one. The second one's just backwards. Okay? So, here's what it would look like on my problem. This time it goes through F2 first. So start at the same point, go to F2. This time, again, I'm going to that vertical line here. Wow, I totally botched that. My bad. Picked the wrong side of that ruler. And then I'm going to start at that point where it met the vertical line. And then I'm going to draw it parallel to the principal axis. And again, backtrack it. Like that. Got one more line left. Just one. Just one. It's the easiest one. It's the easiest one. I'm not lying. It's really easy. Promise. Okay. Last one. Draw a ray through the center. And by the way, the center is where PA, so the principal axis, and the axis of refraction meet. But I think most of you can figure out what the center is. The center's here. So you draw right through the center. Okay. Through the center. Backtrack it. There you go. Okay, we're almost done. Not quite done. Pretty close, though. We're done with the drawing. All we got to do is what it asked me for. Image height, image distance, type of image. So we're looking for image height, which would be HI, height of the image. Image distance, that would be DI. And the type of image, which is just real or virtual. Okay, now you're looking at this and you're like, great, Mr. B, that's sweet. Where is the image, by the way? Be helpful. So here's where the image is. The image is where the three lines intersect. Now you'll notice I don't have a place where they all three intersect. So what you do is you notice there's a little triangle here, little tiny triangle, in between these three intersection points, there's a little tiny triangle. What you do is you find the center of your triangle and you put a dot there. That's your image. Put a dot there. Then you draw a line from that dot to the principal axis in a straight line, straight up and down. Put your arrow, there is your image. There it is. Bam. Okay? Hopefully your triangles are small. Ideally, you don't have a triangle. They just all meet in one place. Okay? If they do, just put your dot there. If you have a huge triangle, you did something wrong. And I'll look at it. But if you got a little triangle, you're fine. Okay, so what's the image height? Ready? I'm going to blow your mind. I'm going to measure it. So, 1, 2, I'm going to just say 2 centimeters. Height image, 2 centimeters. Distance of the image, how far away is it from the lens? Again, measure it always from that vertical line. Okay. 1, 2, 3, 4, 5. Not quite. It's a little past that. So it's not quite there. I'm going to say it's closer to 2/3. So I said 5, so I'm going to say 5 2/3. So 5.66 centimeters. And the type of image is real. Light actually travels through lenses. It actually met in a place where I thought it would meet. So it would be, an image type would be real. Oh, I made a mistake. It's an easy one. See how the image points down? That means HI is negative. Points down, so it's negative. By the way, if you're having trouble figuring out real or virtual, real images will always be upside down. Always be upside down. That's it. That's the problem. You're done. Now, hey, Mr. B, what if I didn't get what if I didn't get 2 centimeters? What if I got negative 1.75? So, I will generally give you a leeway of about 25%. Maybe a little less, maybe a little more depending on the problem. But generally around 25%. So that means if I got 2, and that's the answer it's supposed to be, and you got 1.75 or 2.25, I would still count it right. Okay? So don't feel like you have to be exactly the same as me. Okay? I usually try to make numbers that aren't stupid. Like I try not to make the distance of the image 7/8 or something like that. I try to make the distance of the image either like a whole number or like something like this. Like 0.25, 0.5, 0.75, 0.33, like it's not always going to be perfect, but I try to make it as close as I can so it's not crazy. Okay? And then you just measure the stuff and you're done. That's the problem. That's it. So, like I said, these are really easy if you're careful. If you're careful, they're going to meet up and they're going to be in the right spot. Like, if they line up together, it's almost impossible to be wrong. It's not impossible to be wrong. You could just have gotten lucky, but all your numbers are wrong. It's almost impossible to be wrong if you're very careful and the lines line up. If the lines don't line up, you are wrong. Okay? There's no way about it. If the lines don't line up, then you're wrong. And I can help you with that if you're having trouble. So, trying to think of anything else here. Oh, don't worry if you make a mistake and do inches instead of centimeters. As long as you're consistent, it doesn't matter. You could measure them in knuckles, right? You could do like a straight line. You can measure it in like 3 knuckles away. Like, it doesn't matter. You just got to be consistent in the measurements. So here's what I want you to do. You got 7 minutes here. You're not going to finish problem 1 on the practice, but I'd like you to get started on it just to make sure you guys are able to set them up right. And that way, if you have questions, you can ask me. But work on question 1 here. It's just like what we did, but the numbers are different. So it's a convex lens, same as what we did. Focal length of 3, that's different. Object distance of 4, height of 2. So the numbers are different, but the setup should be the same.